We are in section 1.2, applications with linear equations. So what we would like to do is take a look at I'm going to look at 3 applications here. The applications are word problems. So we're going to take a look at a geometry problem, then we're going to look at a motion problem, and we're going to finish off with a mixture problem. Now the recommendation for solving applied problems, again these are word problems, is given in this box. So instead of writing it, I thought I'd just copy and paste this. This is pretty standard 6-step process, and the steps involving applied problem. Step 1, of course, the key step. You have to read the problem carefully and try to glean from the verbiage of the problem what information is given and what it is that we're trying to find. Once we get past that step, step 2 is to declare the variable or assign a variable to that unknown quantity. Now, in this step, we can actually sketch a diagram or table, whatever helps us figure out the problem. The geometry of the problem is the key step here. Now, once we write down the variable, then we can move on to the next step. After we declared it in step 3, we have that key step again. Every step is really important here, but the step 3 is very instrumental in writing an equation using the variable expressions. Now, everything that we do subsequent to that, which is solving the problem and coming up with a proposed solution, relies on the fact that we have the right equation. So this is a very important step. And in step 4, the proposed equation that was done in step 3, we're gonna solve it. And of course, once we solve it, we have the answer. Then we can state the answer in context of the word problem. And we always have to check just to make sure the answer is reasonable. So if the numbers seem awkward, if they don't seem to fit the problem at hand, then we need to revisit most likely step 3. The culprit would be the equation. Maybe we didn't set it up right. That's why we're getting extraneous or we're getting erroneous solutions. Or in step 4, it's either 3 or 4. We set up the equation, but we just didn't solve it correctly. Maybe we missed a sign and a positive became negative, for example. Now in geometry, because we're talking about the real numbers, so these geometrical figures, shapes, all dimensions are real and positive. So if we get negative numbers for the dimensions in geometry of these different shapes, then we know we've done something wrong. Okay, and of course the last step is to check the answer and just to make sure that it works, which amounts to checking the solution that we got in the equation in step 3. All right, so armed with that, I'm going to actually bring up this, this one exercise that I have copied from a book. So we're going to try to solve this one using the 6 steps above. So in this exercise, we have dimensions of a puzzle piece. A puzzle piece in the shape of a triangle has perimeter 30 centimeters. 2 sides of the triangle are each twice as long as the shortest side. Find the length of the shortest side, and the side lengths in the figure are in centimeters. All right, so now we are given actually a shape here which helps us with the geometry of this, but if we were not given, imagine constructing this shape yourself. You would have to do that based on reading this line: 2 sides, each twice as long as the shortest. So it looks like that's the shortest, and these are twice as long. So for the geometry, from the geometry of what I'm seeing here, looks like this triangle is what we call an isosceles triangle because it has 2 equal sides. So let's do step 1. Well, in step 1, I'm just going to put the steps here, and then let's see how it goes. In the future, we may not write the steps down. We just simply go through the steps without labeling them. Okay, so step 1. Let's see what is given here. It's simple. We're given the perimeter, right? The perimeter, which is the measure of how far around the shape we go. That's given. That's 30 centimeters. Perimeter, called it P, equals 30 centimeters. That's the only given part. And what is it we want to find? Well, we want to be found here. We want to find is length of shortest side. So that's what we want to do. Now, going beyond step 1, we come to step 2. Step 2 is when you declare the variable. So I'm just going to write step 2. We're going to let x be. What is it going to be? It's going to be what we want to find, right? So it's going to be the length of the shortest side. All right, now that we declared a variable, step 3. Remember, step 3 is to actually come up with the equation. The equation for the perimeter, again, of any geometric shape, you just add up all the sides, right? So the perimeter, call it P, is equal to one side is 2x, another side 2x, and the shortest side x. So that's the equation that we need. And we are given that P is equal to 30 centimeters, right? This is from step 1, right up here. All right, so we're getting somewhere with this one. What is step 4? Step 4, we need to solve the equation. So we're going to replace P with 30. And to solve this is so simple. All we have to do is add up all the x's, so we get 5x. And then divide both sides by 5, and x turns out to be 6 centimeters. Okay, and then in step 5, we're going to actually write the answer. Remember, step 5 is state the answer to the problem. And the answer seems reasonable. Slice of pizza, 6 centimeters. It's about 2 inches. Are the US or British system, US system. An inch is about 2.54 centimeters. 1 inch equal 2.54 centimeters. So a couple of inches, that's going to be about 5 centimeters. This is about about 2.5 inches. Okay, that seems reasonable. So step 5 again, we're just going to answer the answer to the problem. The length of the shortest side is equal to 6 centimeters. Now to check, that would be step 6. And in step 6, our check would be this. Well, when I do 2 times 6 plus 2 times 6 plus 6, right? The 2 longer sides and the shortest side. Will this equal to 30? Notice I have a question mark because we're trying to verify. That's 12 plus 6. That's 24 and 6, 30. So that is true. It checks. Therefore, looks like the answer is reasonable, and we have solved this word problem. And there you have it, steps 1, 2, 3, 4, 5, 6. So the key again is the geometry of the problem, and then from that it's going to help us set up the equation a lot of times. Now our next example is going to be a motion problem. So here I have it. The motion problem is in here. In this example, we're given that Maria and Eduardo are traveling to a business conference the trip takes 2 hours from Maria and 2.5 hours for Maria and 2.5 hours for Eduardo, because he lives 40 miles farther away. Eduardo travels 5 miles faster than Maria. Find their average rates. Okay, so let's write down the steps for this one. Step 1 would be to read the problem, which I just did. And I recommend that, not to read it so fast. Maybe I did read it fast. So, because if I read it fast and I don't know what I just read, that's not going to help me. So step 1, we're going to slow down and read it. And let's see. What do we want? We want to find Maria's and Eduardo's average rate. Okay, so that's what we want, right? Let me just put down. We want to find Maria's and Eduardo's average rates. Now the rate in this case would be the same as their speed, how fast they're moving. Okay, now step 2 is, remember, we need to assign a variable in step 2. So because the average rates are to be found, we're going to let the variable represent one of these rates. Okay, so for example, I'm going to let x be Maria's rate, or her speed, how fast she's traveling. Now because Eduardo travels 5 miles per hour faster than Maria, we can express this rate using the same variable. Okay, so what is Eduardo's rate? 5 miles per hour faster. So you can add 5 to that of Maria's, and that would equal to Eduardo's, right? That would be Eduardo's rate. All right. Now, we can write things down, or we can actually set up a table that's going to help us do this. Now, the key formula that we need in a motion problem, you may recall this formula for your algebra days, where d is distance a moving object travels at a constant speed. R is that constant, or average, we call it here. The reason they say average rate is because part of the trip, maybe they go faster, another part they go slower. So on average, whatever they're doing is called the average rate. So that's going to even out the faster and slower pace of their trip. But the rate we assume is constant. And of course, t is time, which oftentimes in motion problem, t is in hours. The key is right here. We have 40 miles in 2 hours. So speed will be in miles per hour. Okay. So there we have our step 2. Now I need to do, it would be the geometry of this. You don't have to draw 2 automobiles, for example. This one, it makes sense to set up a table, distance, rate, and time. So for this, we're going to have, let's say I'm going to put Maria, and then I'm going to put Eduardo in the next line. That's information about the two of them. Okay, so we let x be the average rate or speed that Maria is traveling, and we mentioned Eduardo's is x plus 5. Now we were told that the trip takes 2 hours for Maria up here, 2.5 hours for Eduardo. So that's the given part, right? Maybe I put here, given Tm for Maria is 2 hours, and T for Eduardo is 2.5 hours. That's part of the given information. So I'm going to transfer that into our table, 2 and 2.5. Okay, and now the distance. Using distance as product of rate, speed times time would give us the distance of the moving object. So d is equal to t times r. So that's going to be 2x. And for Eduardo, it's 2.5 times time times x plus 5. So that's his rate times his time times time I know it sounds like double talk. All right, so we set up the table here. Now, once we have the table set up, we need to now the key step. We need to come up with the equation. So I'm just going to label this step 3. The equation that we want to write, well, Eduardo's distance travel exceeds Maria's by 40 miles. Eduardo's travel 40 miles fast. Okay. Let's see. Eduardo, okay, he lives 40 miles farther away. Eduardo lives 40 miles farther away than Maria does. Okay, so we can set their distances this way. Well, for Eduardo's distance, that's 2.5 times x plus 5. That should equal to 2x plus 40. And that's, again, because he lives 40 miles, we were told up here, he lives 40 miles farther away. So we add 40 to 2x. Okay. And then once we set it up, we need to solve this. And that will be step 4. So how are we going to solve it? We're going to distribute 2.5 times x. 2.5 times 5 is 12.5. And this is going to be 2x plus 40. And let's see, subtract 2x from both sides. If I subtract 2x from both sides, we're going to get half an x plus 12.5 equals 40. We then subtract 12.5 from both sides. And let's see, this will give me half x is equal to 27.5. And finally, we can divide both sides by half, or we can multiply both sides by 2. That may be easier. Let me do that. Because I have half x equal 27.5, multiply times 2 times 2. 2 times a half is 1. 2 times 27.5, I believe it's 55. Okay, so that's going to be the value of x. And let's see, we let x be, remember when we declared the variable, x was Maria's speed. Okay, so that's what we just found. Now in step 5, we're going to give the answer. So Maria's rate of travel, let's put this down. Maria's average rate or speed is 55 miles per hour. Okay, what about Eduardo? Eduardo's average rate, remember he was going 5 miles an hour faster, right? Up here, that's x plus 5. So Eduardo's speed is going to be, let me hide that other problem for now. So his rate is going to be 60 miles per hour. And there you have it. So we can see now step 6, we can check this one. We can see that the condition of problems are met. Let me put that just so you see how that's done. Step 6, if I wanted to do that one, well, how about the distance distance Maria travel is 2 times 55, which is 110 miles. Okay, that's how far Maria has traveled. How about distance Eduardo travels? Well, he's going to travel 60 miles an hour for 2.5 hours. So he travels 150 miles. Now, if you look at the difference between the two is 40 miles, which is exactly required by the exercise. We were told that he lives 40 miles farther than Maria. So there you go. That would be an example of a motion problem that we just solved. Now next we're going to take a look at a mixture problem. And there you go. Let's take a look at this mixture problem. In this example, we are given that a chemist, let me move this up a little bit. Okay, a chemist needs a 20% solution of alcohol. She has 15% solution. I'm doing a step 1, by the way, right? Reading the problem. So there you go. Step 1, read the problem and read it carefully. So she needs a 20% solution. She has a 15% solution as well as a 30% solution. How many liters of 15% should be added to 3 liters of 30% solution to obtain the 20% solution? So she has a 15, she has a 30%. These are the strength of the solutions, right? So let's say here's one part. I'll give you a better figure in just a moment here. There you go. Usually mixture problems we add because you're mixing 2 different things. So this one is a 20. Oh, she wants a 20%. Sorry. So let's say this is 15% solution. This is the 30% solution, and that's the final mix. Okay, the final mix. 15% solution. How many liters of 15% X should be added to 3 liters of 30%. We were given that amount is 3L for liters. So that's already given. To obtain a mix of 20%. Now remember, the 30% solution already, that's a fixed amount, 3 liters. And we have so much of the 15%. So the final mix is going to have 3 plus X liters in it. Correct? So now that I've done this, let me give you a better diagram here. And here we are. So I just brought this figure up for us. It's a better figure than the one I had, a better sketch. So we have so much of the 15%, 3 liters of 30%, and the final mix is that. So let's go through our steps here then. Okay, step 1, I read the problem, and we have our given, and we know what we want to find, right? What do we want to find? Let's see, we want to find the required number of liters, right? We want to find how many liters of, we were given 15, right? Of 15% alcohol solution. So that's what we want to find. Now, we need to assign a variable to this one, right? That will be our step 2. You already see what X is. X is the amount of 50%, right? So we're gonna let X be the number of liters, say of 15% solution. Okay, that we want to add. Now, how are we going to do this one? Well, from what you're seeing here, from the sketch of this problem, in step 3, we are about to write the equation now. So if I multiply the liter of pure alcohol in 15% solution, which is 15%, obviously, right? You multiply the strength of the solution times the amount. That will give you, again, the liters of pure alcohol in a 50% solution. And then we're going to add that to 3 liters, right? 3 liters of the 30% solution. So this would be, again, liters of pure alcohol in 30% solution. And that total should equal to the mixture that we want. That's liters of pure alcohol in the 20% solution, right? Which is going to be x plus 3. And you can see that plus the first one plus the second one equal to the final mix. All right, we're not draining anything. If we were draining something, then we have subtraction, but we are adding. All right, so here's our key equation, by the way. Step 4, what was the step 4? I think we want to solve now, right? So how are we going to solve it? That's 0.15x, 0.3 times 3 is 0.9, and on the right side I'm going to distribute 0.2 onto x and to 3, and that's the equation we get, right? So we did distributive property on the right side. Next step, we're going to, let's say I'm going to subtract 0.15x from both sides. 0.15x. So this way x would be positive on the other side, on the right side, as you can see positive 0.05x. At the same time, I'm going to subtract 0.6 from both sides. That's going to give me 0.3 on the left side. And to solve this, we're going to divide it by 0.05, the coefficient on x. So that's going to be what the multiplication property of equations we just did. And that would solve for x. So x is going to be, now 3 divided by 0.05, that should be, 0.3. That's 3/10 divided by 5/100. Without a calculator, I'm going to invert and multiply 100/5 times 3/10. That's going to be 10. 10 divided by 5, 2. 2 times 3, 6. So look like the answer is going to be 6. Right? Without a calculator. Now that we have solved, we can answer the question they asked. So here's the answer. We need 6 liters of 15% solution. That's what should be mixed with the 3 liters. Now the final mix, just so you have it, the final mix is going to be 6 plus 3 equal 9 liters. Remember, we had a 3 liter also, 30%, that was combined with the 6 liters. Oh, the units on X would be L. For application or applied problems, we also attach the units, in this case liters, to it. Now step 6, that would be the check. So what are we going to check here? Well, this answer seems reasonable, right? It's going to check because the amount of alcohol in the 2 solution is equal to the amount of alcohol in the mixture. So if I look at the equation, 0.15 times 6 plus 0.9, that's going to equal to 0.9 plus 0.9. That's 1.8. Let's call these the solutions, right? And on the right side, we have 20% solution, 6 plus 3, 9. And that's 9 liters on the final mix, and that's also 1.8. This would be our mixture, right? So we're looking at, in other words, this is the right side, and here we're looking at the left side of our equation, right in here. Okay, and how does the left side come about is this one. It goes back to step 3. Okay, so there you go. That's an example of solving a mixture problem. Again, just wanted to show you a quick application of linear equations using these 3 applied problems. And hopefully you're going to find this useful. And we're done. We're done with this lecture. Again, as always, thank you for watching.